Hello everyone, I am the Bhargav and I will be taking your class on a topic called matrices. Okay, so what what is matrix? What do we mean by matrix? Let us try to understand about that. So suppose we have a series of numbers. Let's say 1, 3, minus 5, 8. Okay, these are a series of numbers and it can be written in many different ways, right? So means we can write it as 1 3 minus 5 8 in a single row, or it can also be written vertically as 1 3 minus 5 8, right? Also it can also be written as, suppose I am taking two elements at a time, so it can also be written like this: 1 3 minus 5. Okay, so what are the differences between this all of them? So I'm naming them. Suppose this is A, this is B, and suppose this is C. So see, in A there is only one row, and there are four columns, right? There are four columns. Similarly, in the next one, that is B, it is having four rows and only one column. And in the last one, it is having two rows and two columns. Okay, so these are the basic differences in the structure of the arrangement, isn't it? These things, this kind of arrangement are these arrangements are known as matrices. Okay, this kind of arrangements are known as matrices. But these are basically just an arrangement of elements in rows and columns. Okay. Now, how do we basically define a matrix? Okay, we define a matrix as it is a rectangular arrangement, right? It is a rectangular arrangement of different kind of elements. Not only numbers, we can arrange different kind of elements, letters, symbols, characters, anything. Rectangular arrangement of different kind of elements, that is, I could say numbers, letters, symbols, and many more in rows and columns. So this is actually the proper definition of matrix, that a rectangular arrangement of different kind of elements in rows and columns. Okay. Now, while arranging, we need to keep in mind few things. only one condition. There is only one condition we need to keep in mind, that each row should have equal number of elements. Equal number of elements. Let us see what does it mean. So see, in our first matrix, matrix A, there is only one row, so it is, we cannot compare it with any other row, so it has four elements. Fine by that. In our matrix BC, there are four different rows, right? And in each row, there is only one element present, isn't it? Similarly, in our last matrix, matrix C, there are two rows, and in each row, there are two different elements, right? So means in each row there are equal number of elements. Similarly, in each column there should be equal number of elements as well. Okay, means for each row and each column there should be equal number of elements. Let's see. So in the first matrix there are four columns, right? So in each column there is only one element. So that's equal. In the second matrix, matrix B, so there is only one column, so we cannot compare, so that won't matter. In column sorry, in matrix C, there are two columns, and in each column there are two elements, right? So this is the condition which you need to keep in mind. Now, so let's say, so is this a matrix? A, B, C, D. Can you guys tell me, is this a matrix? Let's see. So see, in each column, there are two elements, and in each row there are also two elements. So this is definitely a matrix. Okay. Now what about this one? 1, 5, 6. Yes. So see, there are three elements, but in the first row there is there are two elements, and in the second row there is only one element, so this is not a matrix. Okay, similarly, let's say, let us understand another example. So 2, 5, 6, 7, 9. Okay, this is a matrix of five elements. So see, in the first row there are two elements, but in the second row there are three elements, so they are not equal. So hence this won't be a matrix as well. Okay, clear so far? Now we would go on to the types of matrix. Okay, there are many different types of matrices. Okay, so we would learn about the types now. So the first one, let's say a row matrix. A row matrix is what? A matrix containing only one row. Okay, it is known as a row matrix. Suppose 604. Okay, so see, it is containing only one row and three different columns. So columns won't matter. Only there would be a single row in this matrix. Okay, another one, let's say A, B, C, D, E. Okay, it is also having a single row, so hence it is a row matrix. Let's talk about the next type, which is a column matrix. So as the name suggests, just like the previous one, it should have only a single column. Okay, see, this matrix contains only one column, so hence it is a column matrix. Again, let's say 2, 1. This is also having a single column, so it is a single matrix, so column matrix. Now we should see another type known as null or zero matrix. So what does it mean by null or zero matrix? It means suppose we have a matrix, okay, any kind of matrix containing only zero. Okay, their elements of that matrix is zero and nothing else. So it is called as zero matrix or null matrix. See, suppose this matrix contains only zero. So see, it is a three row and three column matrix, right? It is having three rows and three columns, but the elements are only zero. Okay. Or suppose this or this. These all are examples of null matrix or zero matrix. Okay. Now, fourth type is a square matrix. So, what is square matrix? A square matrix is a type of matrix, special type of matrix, in which the number of rows and number of columns are always equal. Means suppose this 2153. This matrix contains two rows and two columns. So it is a square matrix. Again, let's say 351 432 719. So this matrix contains three rows and three columns. So hence it is a square matrix. Okay. Now let's move on to another type called diagonal matrix. Diagonal matrix. A diagonal matrix is a kind of a matrix which contains elements only in the diagonals. Okay, and the rest of the numbers are zero. Let's say like this. Suppose, sorry, 5 0 0 0 4 0 0 0 9. This is an example of a diagonal matrix. So means only the diagonals are having numbers and the rest of them are zero. Okay, this kind of matrix are known as diagonal matrix. Also, let's say 6002. This is also an example of a diagonal matrix. Okay. Um, the next one, the next one is unit matrix. Okay, the unit matrix is basically a type of a diagonal matrix where the diagonals are one and rest of them are zero. Rest of the elements is zero. Okay, so this is the example of a unit matrix. Also, let's say 1 1 1, and let's start the elements are zero. This is also a unit matrix. Okay, understood? Very nice. Now, we would learn about um, certain operations on matrix. Let us learn how do we add two different matrices. Addition of matrix. Addition of matrix. Let us learn how do we add two matrices. Suppose we have a matrix A which is given as 1, 2, 3, 4, 5, 6, and B which is given as 7, 8, 9, 0, 1. Okay, these are two matrices. We need to basically add them. So how do we add? How do we add these two matrices? So we would have like this. We would have to find the value of A plus B. So simply I would write the elements, the two matrices. Element of matrix A to matrix B. Okay, we would add them. So it's quite simple to add. It is quite simple. Sorry, this one wrong. Okay, so it's quite simple. We would simply suppose this is the first row and first column, right? This element, the location of this element is this element is located at the first row and in the first column, correct? Similarly, on the next matrix, see, this is also first row first column element, so we would add these two elements. Understood? 1 plus 7. Similarly, we would take the second row, sorry, first row second column, and this is also the first row second column element, so now I would add them. 2 plus 8. Okay. This same method would go on and on. Then we would take 3, that is first row third column of the first matrix, and first row second column of the third matrix is 9. So we would add. So this is how we basically add elements of two matrices. Okay, so okay, this is how we do. So its result is 8, 10, 12, 4, 6, 6. Okay, sorry, I did a mistake. A silly one. It should be 2, not 6. So basically, this is the main idea of adding two different matrices. Similarly, the same method applies when we are supposed to subtract two matrices. Means, suppose we have to find A minus B. Okay. So this means what? I would write the elements minus 7, 8, 9, 0, 1, 2. Okay. So these are the two matrices. Now we have to subtract them. So it's the same method which we did in the previous problem. Means we would choose the first row first column element of the first matrix and the second row first column of the second matrix. So it's 1 minus 7 Similarly, I would choose 2 minus 8, first row, second column of the two matrices, 3 minus 9, 4 minus 0, 5 minus 1, 6 minus 2. Okay. And hence we would find our result as minus 6, minus 6, minus 6, 4, 4, 4. Oh, that's quite fascinating. Okay, so this is how we subtract or add two different matrices. Okay, okay, now we would learn to solve problems based on equality of matrices. Equality of matrix means two matrices are equal. Two matrices are equal. So means these kind of problems are generally you will encounter this kind of problems um, in your exams. Okay. So suppose if we have a matrix like a plus b, 5, 2, and ab equals 6, 2, 5, 8. Find the values of A and B. So how do we approach? See, since these two matrices are equal, right? So means we can say the first row, first column of the matrix, this is equals to this, isn't it? Since both of them are equal. So means also we could verify this by doing like this. See, the second row, second column the first row, second column matrix of both of them are equal. Right. Similarly, the second row, first column matrices elements are also equal. Okay, so we could equate both of them um, like this means I can say a plus b equals 6 and ab equals 8. That's it. Now it's quite simple now. Right. It's quite simple to find the values of a. Now we can write um, a equals 8 by b. Now this value of a we can replace it in this equation, so it can be written as, sorry, it can be written as 8 by b plus b equals 6, isn't it? So here see we would get the value of b here, right? Means it would be 8 plus b square by b equals 6. Now we would actually get a quadratic equation like 8 plus b square equals 6b, right? So I can rearrange it as b square minus 6b plus 8 equals 0, right? Now it's really quite simple now. I think you have learned how do we middle term factorize a quadratic equation. So it would be, on factorizing it, it would be um, b minus 4 times a minus 2, sorry, b minus 2, Sorry about that. Which is equals to 0. So I can say the value of b as 4 or b equals 2. Correct? Now I would just simply substitute the values. Suppose in this equation, so when b equals 4, let's say, then a equals 8 by 4, which is 2. And when b equals 2, then a equals 8 by 2, which is 4. Okay, so we have two different values of a and b, so hence we got our result. Okay, this is how we actually solve this kind of problems based on equality. You will be facing this kind of problems a lot, so let's us do another. Find x, y, z and w such that x minus y, 2x minus y, 2z plus w, 2x plus w. This whole thing, this whole thing is equals to 5, 3, 12, 15. Yeah. So let's see what we would do. Let's see. So see, we would find two different equations, right? We would have two different equations like x minus y equals 5, 2x minus y equals 12, 2z plus w equals 3 and 2x plus w equals to 15. Right? If we compare the elements. Now see, if we solve simultaneously, right? So if I subtract these two equations, so we would get the y would be cancelled out, and it is minus x equals minus 7, right? So we have x equals 7, right? Now let's see what can we do. Okay, we could substitute the value of x in this equation. So it becomes 2 times 7 plus w equals to 15. So w equals 15 minus 14, which is 1. So we have the value of w. Okay, we can use this value of x in this equations to get the value of y as well. Means we have x minus y equals 5, right? So we have x equals 7, so 7 minus y equals 5. So y equals 7 minus 5, which is 2. So we have the value of y. Now only one thing left to get the value of z. So it's quite simple. We would put the value of z in this equation. So it's 2z plus w equals 3, isn't it? So it's 2 times z plus 1 equals to 3. Correct? So it's simple now. 2z equals 2, z equals 1. Okay, so we have x equals 7, y equals 2, w equals 1, z equals 1. So this is our requirements. So let's finish our class now. Let's conclude it. So bye bye. See you next week.